Hi, in this video, we are going to study breadth first search. Breadth first search is one of the search techniques used by intelligent agents. Let us look at the background. There is an intelligent agent. We have already studied that an intelligent agent is available in the form of a few sensors, a few actions, and a agent program that will perceive the environment and accordingly select the action. So that is an intelligent agent we have already studied. We have also seen how an intelligent agent serves as a problem solving agent. So problem solving agent, there is a problem. For the problem, we have to find out the solution. So there is a problem for which we have to construct the solution iteratively and say that this is the solution of the problem. So we will have to search for the solution. So searching is done by the intelligent agent. We have already studied that whenever a problem has to be picked up by a problem solving agent, we see the problem as a set of states. We are at an initial state. When we want to solve the whole thing and the solution is available, that is in another state. So we are in the initial state. At the initial state, we will have a few possible actions. From a particular state called state 0, if you take an action, it will take you to state 1. So it is improving. Then you take another action, state 2. You take some other action, state 3. And finally, we will reach at the goal state. The goal state will have the solution. When a state is given, it is associated with a set of possible actions. It's possible to take either action number 1, action number 2, action number 3, or action number 4. Each one will take you to a different state. Then you will have to continue your journey. And now, we want to begin with the initial state and choose the actions in such a way that you reach at the goal state. So that is called the search for solution. So do one action, you reach another state. Do another action, reach another state. So you are searching for the solution in this way. Now, if you consider a problem, it has several states. We have to reach the goal state. For example, if you consider the picture, in this problem, there are 7 states, 0, 1, 2, 3, 4, 5, 6. 7 states. Assume that 0 is the initial state. So the problem is represented in the form of a graph in which the vertices are the nodes. Each node represents a state. For example, 0 is the initial state. When you are in the initial state, either you can do this action or you can do the vertical action. Each edge represents an action. So 0, there are 2 possibilities. The edge 0, 1, it is an action. If you do this action, you will reach in state 1. Whereas if you do the action 0, 6, you will reach in 6. Then you will have to take a further. So that is how we are moving forward. Now, this is a non-linear search. Normally, if the data are given in the form of A0, A1, A2, A3, AN and search for the solution, it's called the linear search. The search of a graph for solution is a non-linear search. For example, let us consider a simple example. Assume that 0, 1, 2, 3, 4, they are all pharmacies, medical shops. Each one represents a state. Each one is a medical shop. I am initially at 0. What is the problem? The problem is to buy medicine X. I have a prescription which says this is the medicine which we have to buy. What we can do is I have to search among these pharmacies and find out a pharmacy in which the medicine X is available. So you start with 0. So in 0, first verify whether the medicine is available. Supposing it is not available. Then where shall I go next? How to search? Then go and search 1. So I can verify whether the medicine is available in 1. If it is not available in 1, then I can either try 6 because that is a neighbor. For 0, 1 is a neighbor and 6 is a neighbor. I can try with 1 and I can try with 6. Then I can try with maybe 2, maybe 3. So that is how finally we have to arrive at a medical shop where this medicine is available. So that is what we call it searching for solution. What is the solution? Solution is we find a medical shop where the medicine is available. Now, basically, there are two fundamental searching techniques proposed. Two fundamental searching techniques. One is called breadth first search. Actually, the other is called depth first search. What is breadth first search? Breadth first search proposes that this is the initial state. 0 is the initial state. What are all the ones which are available nearby, the neighbors? So breadth means neighbors. So neighbors are 1 and 6. So initially you must search whether 1 has the medicine. If not, then 6 has the medicine. So they are neighbors. Neighbors are nodes at a distance of 1. If it is not available in all the ones which are in distance 1, what shall I do? You look at all the shops which are at distance 2. Look, the node 2 is at a distance 2. Node 4 is at a distance 2. Node 5 is at a distance 2. So I will have to find out whether the medicine is available in 2. If not, find out whether it is available in 4. Find out whether it is available in 5. Because they are the 3 nodes at a distance of 2. 0, 1, 2, distance 2. 0, 1, 4, distance 2. 0, 6, 5, distance 2. If it is not available, then go for distance 3, distance 4. In this way, you will have to go. If at any point in time, if the medicine is available, then it becomes a successful search. Success, return the solution. You buy the medicine and come back. See, the thing is, the solution for the problem is search for the solution. If it is not available anywhere, complete your search and say that it's a failure, the solution is not available anywhere. Finally, we will decide that. So, what is the breadth first search you're proposing? Breadth-wise. So, all the neighbors, then the neighbors of the neighbors. So, they are all distance 2. Then the neighbors. So, that is how distance 1, distance 2, distance 3 and so on. That is how the breadth first search works. Let us look at the way it is organized. So breadth first search says it starts from M0. You find out all the neighbors. So check whether it is available in M0 first. If it is available, then we are done. If it is not available, then what are all the things which to be searched now? All the neighbors. So what we shall do is we will maintain a queue. A queue is a first in first out mechanism. So you maintain a queue. So in M0 you search. If it is not available, then what are all the things to be searched next? The neighbors. So all the neighbors, you keep it in a queue. From the queue, you pull one, you pop the first entry. You find out whether the solution is available there. If the solution is available, we are done. If the solution is not available, then what shall we do? After exploring the node, we must add all its neighbors in the queue. So you put all the neighbors in the queue at the back. So if you maintain this order, if you maintain this approach, we will use breadth first search and systematically proceed. Shall we write an algorithm for this? Yes. Look at it. A high level algorithm for breadth first search. What is the input? Input is a graph in which each vertex represents a state. Here, the medical shop is a state. Here is a medical shop. If we can find out, we can explore whether it is there. The vertices are numbered as 0, 1, 2, 3, n minus 1. Totally, how many nodes are there? N nodes are there. It means there are n states. So we are searching all these n vertices one by one and verify if the solution is available anywhere. If the solution is available in 0, we are happy. Otherwise, go to the next, go to the next, go to the next, and find out the solution wherever it is. If it is not available, then we cannot do anything. We will say that the solution is not available. This is not a linear set of nodes. This is a non-linear set of nodes. That is why breadth first search is designed in such a way that you see breadth wise you expand and go. So what is the problem here? A simple problem is a prescription showing a medicine X is given. I want to find out whether this medicine is available in any of the shops. The initial state is I am in 0. So now after searching everywhere, what is the solution? Find the shop where the prescribed medicine is available. If it is available anywhere. The path from initial state 0 to the node where the medicine is available has to be found out. So that is the purpose of it. That is the solution of the problem. If it is not available anywhere, then finally we will declare that it is a failure. The solution is not at all available. So that is how we have input and output. Let us see how we are going to run it. Look, first, what is the first step? Check if the medicine is available in shop 0. If the medicine is available in shop 0, you are in initial state, so you are done. Now, if it is not available, then you assume D equal to 1 because we are going to search in the nodes at a distance 1 from the initial state. So what are we going to do in 1? While there are vertices at a distance D from the initial vertex 0, from the initial vertex 0, find out if there are vertices at distance D. D means 1 here. There are neighbors, so all the neighbors will be available. So for each neighbor, we have to do find the list L of all vertices at a distance D. So at a distance D, there are some vertices. So call it L. Now, what is L? L is set of all vertices at a distance D, distance 1 initially. For each vertex, check whether the medicine is available in the shop. If it is available, then it is a success. So end the algorithm. Otherwise, what should I do? Increment D, that is a D equal to D plus 1. So go to the next one. So what do you do? So you first collect all the vertices at distance 1 and call it a list L. In L, for each one you verify whether it is available. If it is not available, then go to the vertices at distance 2, D plus 1, D equal to D plus 1, and then you repeat. If we have not reached success and you reach the end, so conclude that the medicine is not available anywhere. So you can close finally saying that, hey guys, I started from the initial state. I searched all the nodes which are at distance 1. It is not available. I searched for all the ones at distance 2. Not available. Distance 3. Not available. 4, 5. So at some point in time, there is no vertex, then we will stop. So this is called breadth first search. So for example, let us assume 0. This is the starting point. If you start from 0, verify whether it is available at 0. No, the medicine is not available here. Then what shall I do? D equal to 0. This is iteration 0. So L0 is the distance at 0. It's the same vertex. So if it is available, if the medicine is available in vertex 0, we end the successful search. Then we are done. If it is not available, it's not available in 0. What shall I do? D equal to D plus 1. So we are going to look at distance 1. Look at it. What are all the shops at a distance 1? So we call it L1. L1 is the set of nodes at a distance 1 from the initial state. So look at it. 1 is at a distance 1. 6 is at a distance 1. So 1 and 6 are the vertices. So now what shall we do? We will verify whether medicine is available in 1. If it is not available, then verify whether it is available in 6. So because these are the two vertices at a distance 1. If you verify, if the medicine is available in any one of these two, our search ends successfully. If the medicine is not available in 1 or 6, our search continues with D equal to D plus 1, which is a 2. Now that is iteration 2. So what is iteration 2? Iteration 2 is find out all the shops at a distance 2, 1, 2, 1, 2, 1, 2. So breadth-wise, it will be at so many places, but all of them are at a distance 2. Look at it. 2, 4, and 5. Because look at it. 2 is at a distance 2. 4 is at a distance 2. 0, 1, 4. 5 is at a distance 2. 0, 6, 5. So 2, 4, 5. There are 3 nodes in L2. We check if the medicine is available in 2 or 4 or 5. One by one, we will have to search all of them. If the medicine is available in any one of these, our search ends successfully. Here is the medicine. Otherwise, our search continues with D equal to D plus 1. 3. Iteration 3. So iteration 3, we collect all the nodes at a distance 3. Look, already 0, 1, 2, 4, 5, everything is done. Only 3 is missing. So 3 is at a distance of 3. You can go 0, 1, 2, 3 or 0, 6, 4, 3. Either way, it is at a distance of 3. We will have to now check whether this vertex 3 has the medicine. vertex 3 has the solution. We have to find out. If it is available, then it is success. Otherwise, we will let us search with d equal to d plus 1. D equal to d plus 1, which is 4. Now, look at it. Is there any vertex at a distance of 4? No, beyond 3, there is no vertex. So, L4 is empty. There is no vertex at a distance of 4. So, we have checked all of them. I have verified in every medical shop and the medicine is not available. So, we conclude, we end the algorithm saying that the medicine is not available. That is the unsuccessful search. So, this is how the algorithm works. Now, let us see how we have solved the problem. Here, look at it. There is a state space with 7 states. 0, 1, 2, 3, 4, 5, 6. Each vertex is a state. It represents the state. This is picked up. We started from 0. At the first iteration, at the 0th iteration, we verified whether the medicine is available in 0. At the first iteration, we verified whether it is available in 1 or 6. So, after 0, it is 1 or 6. Then, afterwards, 2, 4, 5. But 2 is a neighbor of 1 and 4 is a neighbor of 1. So, 2 and 4. So, that is how. So, 1, then from 1 we can search, we can find out 2 and 4. But before that, 6 will be there. So, in the breadth first search, we start with 0, then 1 and 6, then the neighbors of 1. What are the neighbors of 1? 2 and 4. What are the neighbors of 6? 5. So, 2, 4, 5 are searched in this order. Then, what is the neighbor of 2? 3. What is the neighbor of 4 to be searched? Nothing. Neighbor of 5? Nothing. So, in the BFS, if you draw the vertices on how we access them, that is called the breadth first search tree. So, BFS tree has all the nodes, and from 0, the next one is 1 and 6. So, for 1, the parent is 0. For 6, the parent is 0. So, 1 and 6 are the children of 0. Then, from 1, what are the nodes further you are visiting? Are 2 and 4. Similarly, for 6, it is 5. For 2, it is 3. So, this is called the BFS tree. The order in which the search happens is first 0, then 1 and 6, the neighbors of 1 which are in the next level. So, 2 and 4, and then 5. Then the neighbor of 2 which is 3. So, this is how we form the BFS tree. So, in breadth first search, we search and at the end we will get the BFS tree also. So, the BFS tree will tell you how the search will have to happen. In this video, we have seen what is searching, intelligent searching, how an intelligent agent which is trying to solve a problem is searching. In that, I told you, breadth first search is searching in the breadth wise. It is expanding in the breadth wise. We have seen a high level algorithm for the same. Thank you.